It's my pleasure to introduce you to Mattias Kerschaggl. Welcome, Mattias. So he's from the company EVK DI Kerschhaggl. He will talk today about from real-time hyperspectral edge computing towards a data learning center. Please, Mattias, the floor is yours.
Thanks for the kind introduction. So I'm going to talk a wee bit about the potential of offline big data analysis in conjunction with hyperspectral imaging. First of all, I would like to introduce ourselves. Who is EVK? We consider ourselves to be experts in the field of industrial imaging, and our core expertise lies with hyperspectral imaging next to conductivity imaging and the data analysis that is dealing with this kind of data alongside of color cameras and so forth. And we provide complete solutions to our customers, so in some sense we are also system integrators. So the mission of our company would be that we connect sensors and data, and that we infer the key information from this data, which is valuable and useful for the customer for sorting predominantly and monitoring applications. So the areas we are dealing with, where we are acting, is apart from sorting bulk flow material, is monitoring applications where you basically look into the quality and the condition of a product. And what we also do is we do inline analytics. That means that metrology that's typically done in a laboratory can be transferred into the production line for 100% quality control. And this is done by using our sensor systems. The markets we are working in is food segment, so for instance, food quality control, as well as waste management, recycling, chemical industry, and a little bit of mining and pharmaceutical industry. Our customers are located throughout the world, but the majority is in Europe, but we do have also an office in Asia, in Seoul, South Korea, and customers in the US. So our history shows that there's a proven track record in the area of sensor-based sorting. So we are out there since around about 35 years. We started with color cameras and moved over conductivity imaging into hyperspectral imaging since the year 2006. And there we learned that data is ever more growing, and in order to harness this data correctly, you need to do algorithms, you need to do machine learning and artificial intelligence to arrive at a good business sorting decision. So we were investing more and more into software development and real-time computing, and that's where we are today, and that's the reason why I'm standing here today, because I want to tell you about the potential of this evolution. So the ecosystem we are living in starts with the sensors that are either proprietary, we're doing them ourselves, or could be third-party sensors whose data is fused in a so-called computing sorting engine. This is typically happening in the edge, because you get this sensor data at very high rates, very high speed. We are talking about product speeds of several meters per second, and that means that the data that you're getting in and the bandwidths, as you know, are growing every day, that this decision has to be made within a few milliseconds, and therefore you need good algorithms, good classifiers to do the right decision, to sort out the right product and to separate good from bad, for instance. And you see in this middle layer where the actionable decisions are happening, that we are now moving from the edge computing more into an offline data-based realm, because it's important to know the best classifier you will be using in the edge in order to have the best result. And this ecosystem we are currently building up more and more to higher levels of an integrational level. So to describe this value chain, of course you start with the data acquisition. There is no AI without good data, so otherwise you will end up in a garbage in, garbage out scenario. So what we are typically doing is we get our customer samples and qualify them in inspection lab, because it's really important that you take notice of the key building blocks, choosing the right illumination, choosing the right wavebands, fusing the data in a correctly format, thinking about local resolution as well as bandwidth and product speeds. And it's good to know the ground truth of your data, because if you do not understand your data, you will not be doing a good classification. So it all moves on to the edge computing, where you need to take care of this high-dimensional data. So hyperspectral data is so information-rich, but you have so short time, so the decision, the fast data to feature reduction is key. So in real-time applications, we make sure that this is happening very fast, and we have to think about stuff like bandwidth, latency, jitter, and computing power to accommodate the needs of the customer. The trade-off in the edge, of course, is that you chuck away data, and you cannot be sure if the data you chuck away, that you're getting rid of, wasn't crucial in some sense. And this is the reason why we need to find out before we go into the edge what is the best algorithmic approach. So once you have the features, so you extracted the information-rich part of the data, data becomes knowledge, and this knowledge is used by the customer by doing higher level statistical analysis in order to increase yield, in order to increase quality, and only then it becomes precious to the customer. Before it's just data, could be noise, and it's our job to separate the one from the other. So in this chain, where we start with the sensor data that we would upload to the database we are currently using, which is an offline analysis tool. The information, the data set can be assessed before it goes into a classifier, before you start tuning a classifier and before you're really doing machine learning or artificial intelligence. You need to know how good is your data set and if the application you're dealing with is in theory solvable given the data. So after that, after this explorative Einsatz, you are going to identify the best-in-class algorithm, because you just open up the textbook and you know there are hundreds of machine learning algorithms out there, and you have to know which one is the best, or at least a suitable one to solve your problem. And this problem cannot be solved by a human being easily. It should be automized, and that's what we are doing. So after having answered this question, you start training the classifier, and then only then you deploy it to the edge and bring it into the production line. And then you can do whatever you want to do, like starting feedback loops, doing higher order correlation in a production site, whatever. Probably there's no border to what you can do there. So in this from data to information to knowledge route of attack, we are dealing, as I said, with a vast amount of data. So one capture of a hyperspectral imaging camera in 1 second generates several hundred megabytes of data. So how can you tell if this data is good or not? it's not so easy. So it's computationally very costly to find out if this data set is fair, or if it's noisy, if it contains the information you really need. So what you have to do is to introduce some kind of metrics to assess the quality of your data. And as is shown on this plot here, this problem is growing exponentially in terms of memory. So it costs you a lot of computation time, therefore it costs you a lot of money. So, and there's another problem. It's not only the data and how it's set up, it's also the representation of your data. So we're talking about data and data spaces. So on this slide, you see a hyperspectral imaging acquisition of a steak, of a schnitzel on a plate with some background. And for a human being, it's easy in the representation on the upper right corner in this plot to see which data points belong to which class. But for an algorithm, this might be a problem that's not so easy to be solved. And those algorithms are prone to this representation issues, as you can see in the lower left corner of the plot, where you see two clusters of data that you can separate with your eye easily, and a cluster algorithm can also separate them. But if I change just the aspect ratio and the dimension of the representation, could happen because you're using different units in your data set, the algorithm misclassifies the data because you just changed some dimensional parameters. And this shouldn't happen in the field. This shouldn't happen. This would not happen to a human being, but it happens to a machine. So you have to make sure that this doesn't happen beforehand. So that's why we came up with some metrics that allows for an automatic key information retrieval by quantifying the dissimilarity in the data. And you don't have to know anything about your data. You don't have to know what it is. You don't have to know how many classes it contains, how many different materials. This algorithm would just tell you which data is dissimilar to other data, and this gives you a natural grouping of your data set, and therefore a quantifiable number if your data set is good or not. And as a customer, before you invest a lot of money and try out to parameterize classic algorithms, it's possible to tell whether the application you're thinking about is solvable or not, yeah? Or if it makes sense to dig deeper to train a classifier. So to bring this to a bottom line, we are always talking about data and with respect or versus relevant information. I'm not interested in data, I'm obviously interested in relevant information. And usually, or state of the art, the inference of the key information is rather costly. It costs you time and computing time and money. Because the phase space for the classifiers becomes ever more huge. It becomes bigger and bigger as we speak because the data rates are increasing and the computation power is increasing. So usually it's a lengthy process to do it in a classical way, to set up a machine, a sorting machine or so, and using trial and error ansatz because it needs an expert, it needs a human being who knows the data and who knows how to tweak the system. But this doesn't scale very well, because if you want to sell it again and again, it should be possible to do it by integrating itself in an automized manner. So the key questions that arise and that we ask ourselves and our customers, and by using the offline analysis, is the key information contained in your data set at all? What is the best classifier that would solve your application even before starting training? And what would be the theoretically best performance in the edge that I can arrive? Because it's nice if you can solve a problem, but if it takes you days or hours, it's not fast enough, then you will not be able to bring this to the market. So only state-of-the-art algorithms will allow for quantifiable result to answer these questions, and that's what we are putting forward here. So the bottom line is we are looking for customers, for industrial partners who want to get out more of their data, who want to know if their data sets are in principle useful for their applications, in conjunction with their applications and the sensors they're using. And it would be a pleasure to welcome you at our booth to discuss your projects and to dig a little bit deeper using modern state-of-the-art algorithmic approaches. So in this sense, I'm looking forward to welcome you at our booth, number 10E21 in Hall 8. And yeah, would be great to talk to you. Thank you. Hall 10, I just learned. Yeah, I was confused, it's wrong. Hall 10, sorry, my mistake. Thanks for bearing with me.
Thanks a lot, Matthias. Thank you. So, in the time we wait for people to get warm up and send you questions, I have an EPIC question. That is the thing that we like to do in EPIC. So EPIC has, at the moment, more than 700 companies that is committed to photonics, to integrating photonics and even using photonics. And so I really much liked your last slide saying that you're open for partnership. Of course, you look for customers, but we are here also to listen to how you can be helped also in collaborations.
Sure.
And, do you have some ideas that you can throw to the floor and to me?
I mean, I think the problems that we are tackling today in this community, they're so big that not a single company will solve them. So it will be strong partnerships who will bring us forward here. And I can imagine, I mean, what's really important is data. So you can have the best algorithm, it's worth nothing if you do not have the data. So I'm looking for partners who have good data sets, labeled or no, for supervised or unsupervised learning, doesn't matter. And of course, we also can help people who are into algorithms with the right tools to get their data by using our sensor systems, for instance. So that's where I see a strong interfacing.
Yeah. That's very interesting. And then you were mentioning at the beginning, you do your own proprietary sensors, but you're also open to other, so like collaborators.
Exactly. So if there's somebody who has a good sensor with, let's say, information that is not covered, wasn't covered in this talk, yeah? I'm always open to talk about integration of such a sensor system into our ecosystem if it brings the solution to the market.
Okay, and this is more like broad in spectrum, like you wrote a near-infrared and hyperspectral imaging application. Is it that or you have even a broader?
I would say everything that the electromagnetic spectrum can do for us.
That's a good
Gamma rays, probably not, but yeah.
That's a good one. Then we have a broad spectrum that we can make Matthias happy, so very good. Thanks a lot. So if there are no questions, we just thank Matthias again. Thank you.
Thank you. Thanks for having me.